Welcome to Excellential School of Chemistry. This is the qualitative analysis of 2025 WASSCE examination chemistry. C is a mixture of an organic compound and an inorganic salt. Now you see the instruction there, every detail is there. So put the whole of C into a clean beaker and add water and so on. So here is the mixture. Here is the solution. Here is the solution. It's dissolving still. It forms a blue solution. So in the report we say that forms a clear blue solution, and in the inference a transition metal may be present. Now on getting to the B portion of the mixture plus sodium hydroxide in drops, then in excess, followed by heating. And in drops this is the drops. You can see blue precipitates in drops. In excess we can see that the precipitate remains. It forms even more precipitates, although it seems to be dissolving gradually, but it has not dissolved anyway. So we write that the PPT remains. So we can infer that copper 2 may still be present. The copper 2 ion may be present. So here is our report. Light blue precipitate is formed, and in excess the PPT remains. So we are suspecting copper 2 ion because we have a subsequent test. So copper 2 ion may be present. Now I wouldn't report the heating yet. Let me just do that of ammonia so that I can report everything together. So here is the sample, aqueous ammonia in drops. You see the blue precipitate inside in drops. So let's do excess and see what happens. Meanwhile, the other one we added sodium hydroxide. You see the PPT is still there, even in excess. It's still there, a light blue PPT. So we see that on adding the aqueous ammonia in excess, you see the deep blue solution. If I add more, you see that the solution becomes deeper. So you can see that the deep blue solution is there with aqueous ammonia. That's confirming that copper 2 ion is present. We are going to report it, but then we are going to also do heating. We are going to do heating on this and on this other one too. We are going to do heating on the two. So this is the solution of with sodium hydroxide, heating it in a water bath, and also with aqueous ammonia. The two of them are here. We heat for a few minutes, okay? So far we can see this is the one to which we added sodium hydroxide. Is turning brick red already, but the other one is still there, is yet to turn. But it will still turn brick red with time. You know that we added ammonia to it. Ammonia is a weaker base, so it will take time. But the one to which we added sodium hydroxide is turning brick red already. Yes, so we still allow them a few times. So while these ones are heating, this is the original sample again. That is the solution. Let me add phenolines A and B to it. So here is it. I've added phenolines A and B to it. No apparent change. Let's do some heating. So we put it here and heat with others. Oh, some accident happened. Something broke. I dropped it and it broke. But now you can see that even the water has turned brick red. The tasty broke over. But you see it has turned brick red. Everything has turned brick red. That shows outrightly that there is the presence of reducing sugar. And aldehyde is present. Presence of reducing sugar. As an aldehyde is present. Why this other one is yet to change? This one is yet to change anyway, but the others have responded. So we've got two. This one to which we added. The one to which we added sodium hydroxide, it has changed to brick red. And we also see this one now is the phenolines solution. Okay, everything has changed to brick red. The only one that did not change to brick red is the one to which we added aqueous ammonia. but I think we've got our results anyway. So here is the final sample, the first sample. Let's add dilute mineral acid to it, dilute HCl. And on adding dilute HCl, no observable change. Let's now add barium chloride. You see what we see on adding dilute barium chloride, white precipitate. If you add more barium chloride, you see it doesn't change, doesn't dissolve, okay? The white precipitate remains. Yes, that shows that sulfate is present. Sulfate is present. So here is it. When we add it to the sample, we added dilute HCl. To the sample, we added dilute HCl. There was no observable change. That means that carbonate is absent. Carbonate is absent. Now we have, when we added barium chloride in excess, white precipitate forms, which means that SO42- is present. So, but please, when you go into the hull, you have to check the equations correctly. This must not be the order, and all these equations must not be there. But sure that these are the ions that would be present, okay? Yeah, thank you very much, and these are the samples that we present. Thank you very much. I'm wishing you the best. This is Excellencia School of Chemistry.